In this video, I'm going to explain how to do the integration if inverse trig function is involved. So the objective is to not to integrate inverse trig function, but use inverse trig function and also completing the square. So let's review here. What's the derivative of sine inverse x? If you recall, derivative of sine inverse x 1 over 1 minus x squared dx. Derivative of tangent inverse x is 1 over 1 plus x square dx. So we are going to use a inverse trig function to integrate the rational function. So for example, if we have antiderivative of this, so antiderivative of 1 over square root 1 minus x square is derivative antiderivative get cancelled and you get sine inverse x. Okay, so antiderivative of 1 over 1 plus x square is derivative antiderivative get cancelled and we get tangent inverse x. So this is the technique we are using to integrate a rational function. Please know that you are not going to know that you will not see this. This is not in the curriculum, not in AP curriculum. This is not we are doing. We are going to do it antiderivative of fraction where answer is a sine inverse x. So this is what we are knowing, not this. Okay, so let's flip the paper and on page number 29 you have these rules which I just explained. Now question here is why a? What is a? So in AP exam, less likely you are going to see 1 there. That is very obvious. We are not going to see 1. So u is a differentiable function, a is a greater than 0. So this is a lot of algebra manipulation involved. And if you keep it 1, then you have to factor out a and then you have to divide a and like a half full of paper to take care of a. So I would just say this is my thing. And this symbol is telling you that suck it up. Just memorize a couple of more formulas and suck it up. This is important and you have to memorize so many more formulas. Might as well couple of more. So another thing, know that sine inverse is also written as arc sine u over a. Arc tan, know that tangent inverse is also. Okay, so how do we know the difference between two? It's a very easy way to see. Tangent inverse is the only one has 1 over a as a coefficient. How you get this? Again, it's a one full for page of algebra involved where you have to divide everything by a square and then there is a derivative of 1 u over a is 1 over a and then a lot of work. So just memorize these formulas and that's all. So tangent inverse always have a 1 over a in a coefficient. So let's take a look at a couple of examples. Here, various techniques are involved. So you have to know that radical 1 minus x squared. So this is the easy one, sine inverse x plus c. Know that that is also as arc sine of x plus c. You don't have to write both of them, but I'm writing both. So let's do the third one, easy one. We can easily identify tangent inverse x plus c. This is very, very popular fractions, which we are going to use in unit 10 also. This is also, you can say, arc tangent of x plus c. Okay, so left is this two. So let's compare here. If it is a 1, it's easy to do. So can we see anytime radical means sine inverse. Sine inverse means a value is a 2. 2 square. A is a 2. So if I use this formula here, what will be the antiderivative is sine inverse x over 2 plus c. Done. That's your answer. Here the value of a is a square root 5. A is a square root 5. Note that we have to write a square plus u square. So square root 5 square plus x square. And if I apply this formula here, answer is 1 over square root 5, which makes it 1 over a. Tangent inverse u over a, u is x, is a square root 5 plus c. Not much math to do. You just have to know which formula to use where. If it is a radical, then it's a sine inverse. No radical, you can't factor, then it's a tangent inverse. If you can factor 1 minus x square, know the difference. Again, know the difference. We will review these, all the various techniques. If it is 1 minus x square, this is comes PFD because you can factor x plus 1 and x minus 1. So know the difference. If it is a plus x square, that means you can't factor. Let's take a look at one more here. Oh, I'm going to use this. This is again very interesting one. I'm going to bring the answer from 3. This is a definite integral. So if it is a definite integral, you have to know the trigonometry. So can I say tangent inverse x? We do not write a c. Remember partial, this is a second fundamental theorem of calculus. So this is f dt. And we have to do tangent inverse x minus tangent inverse 0. Sorry, not x, but the 1. And tangent inverse 0 is a 0, tangent inverse 1 is a pi over 4. So this is the answer. You must know the inverse trig function. Okay, so let's take a look at this one. If I rewrite, then a is a square root of 5. And if I rewrite this, so let's rewrite this integral 1 over square root 5 square, which will give me 5, minus square root 2x and a square. That will make it 2. Square root 2 square is a 2 and x square is x. And now you can apply the proper formula, which will make it, now here involves u sub also. So what's the derivative? U is equal to square root 2x. Du is equal to square root 2 dx. Because I don't have a derivative of this is here. Remember the chain rule. So if I apply that properties here, I can rewrite again 1 over square root 2 and 1 over square root 5 square minus u square du. And that will give me 1 over 2 sine inverse. Remember u is a square root 2x divide by a, which is a square root 5 plus c. So inverse sign and then u sub involved. Okay, so I'm going to keep this here again. You can see that this looks like, I'm sorry, this looks like tangent inverse, but that's not. This is a normal u sub. Check it out. Number 7 is a normal u sub. Okay, so let's take a look at a couple of more examples here. These are, we have very challenging problems here. Okay, so sorry, here looks like inverse sine inverse. Why u sub doesn't work? Because derivative of 2x, let's check it out. Why u sub doesn't work? Du is equal to negative 2x. What would you do with these two? So no u sub doesn't work. This is very interesting. You have to split the integral into 2 factors. Normal u sub doesn't work. Okay, so sorry. Now here, this piece u sub works. U is equal to 4 minus x square. Du is equal to negative 2x dx. You have x, so negative 1 half x dx. So I'm going to rewrite this integral. Only 1 half piece. I'm only working on this one piece. Negative 1 half du, which is negative 1 half power rule u to the negative half, right? If I rewrite, so the power rule is u to the positive half over half. We are not writing c yet because we still have to go to the second piece here. Okay, so this is a second piece. Now here, this is working very well as a sine inverse, right? So 2 outside. So 2 sine inverse x divided by 2. Okay, so let's put them all of them together. Remember, this comes here and then this u. So if you must bring it down, this half get cancelled. Negative u to the half. What was our original u? You must bring down the original plus 2 sine inverse x over 2 plus c. So this is pretty mind-blowing integral where we have a u sub involved for half the problem sine inverse involved. It's a very interesting problem. We have another very interesting problem here. Let's take a look at that. You cannot factor x square plus 4, so no PFD. You cannot cancel out any of these, then you don't belong in this class. That's a serious crime if you cancel any of these. Y u sub doesn't work. Let's check it out. X square plus 4 du is equal to 2x. Well, I have a 2, so what do we do with that? So let's break this integral into two pieces. X square plus 4, 2 x square plus 4. Clearly u prime over u, so this is 1 half ln x square plus 4. Some of you are wondering how am I working so fast. So remember, u prime over u is ln u. So derivative of x square is a 2x. I have a 2, so you can balance it. That's why 1 half ln u plus. This is a tangent inverse, right? So 4 plus x square or x square plus 4. So 2 is a separate. Now remember the formula is 1 over a tangent inverse x over a. So this a is a 2. So 1 half tangent inverse x divided by 2. And don't forget c. So final answer 1 half ln x square plus 4 plus tangent inverse x over 2 and c. Another very interesting question. Okay, so let's take a look at this one last one here. Again, we are using various techniques of integration here. So this one, you cannot touch it until you do the long division, top heavy. You must do the long division. So I let you work on the side on the long division and I give you the answer. You get something like this. Or if you are interested to learn the shortcut, let me explain the shortcut. Is some of you will figure out what is this shortcut. So x cube over x square is x plus you need something. So x times x, x cube, and x times 1 is a x, but you don't have that, so that's a negative x. This is the mental math about long division. And this case, antiderivative of x is x square over 2 plus antiderivative of this. Remember I said u prime over u is ln u. So let's take a look at here. Derivative of 2x, x square is a 2x. So I can uh, fix it. Negative half. So negative 1 half ln x square plus 1 and c. So that will be your number 10. Okay, so you are going to work on the homework, which is the next page. Suck it up again. Answer key is posted here. I give you the hint here. U is x minus 1 square. U is a t square. And the most important one, don't forget that this is the last one, is here. Uh, this question is you have to understand the area of the region. So you must set up between 0 to 1 and 4 minus x square dx. So this is a definite integral. Make sure you do f of b minus f of a. Answer is pi over 6. The same thing goes here. Definite integral. Once you do it, you have to substitute root 3 over 2 and know the trigonometry. Answer is pi over 6. Okay.